my dear students. This is Dr. 𝗵𝗵𝗺, your biochemistry faculty. In this video, we are going to discuss about the water-soluble vitamin B1. Now, B1 is again a very important vitamin, and the most important point to remember about the water-soluble vitamins is that all those vitamins which belong to B complex, they are actually used as coenzymes in so many biochemical reactions. So, let's discuss vitamin B2. Obviously, first of all, a water-soluble vitamin, right? And the most important point to remember about it is what is its active form. So, if we talk about the active form of B2, it is FAD and FMN, and it is known as, it is called as riboflavin. And since it is called as riboflavin, so FAD stands for flavin, adenine dinucleotide, and flavin mononucleotide, right? And if we talk about the structure of riboflavin, it has this type of structure. As you can see here, it has a ribitol alcohol. And the most important function of this is that B2 and B3 are basically known as redox vitamins also. B2 and B3 are known as redox vitamins. Why? Because they are required for the oxidation and reduction reactions taking place in the body. Because redox is what? Ki both oxidation and reduction will take place with the help of this. Now, what are the important features of this vitamin? Now, if we talk about the important features of this vitamin, the most important one is cooking cannot destroy this vitamin. And this is yellowish in color. Okay, so if we talk about, it is yellowish in color, right? And that is why it is also known as Warburg's yellow enzyme. Warburg's yellow enzyme, right? And that is why you must have observed whenever we are having B complex, there will be a slight change in the color of the urine, which is normal. Why? Because of this B complex में B2, which is yellow in color. So I can say that if we have B complex vitamins, right, it will give yellowish color to the urine. Or you can say yellowish color in urine is due to this, yellowish color of urine. Then third important point about this is cooking will never destroy this vitamin. Even if we cook, so cooking does not destroy this vitamin. Very important. Right. Now, the question is, what are the reactions in which it is used as a coenzyme? So, just now I told you it has two active forms. One is FAD, the other is FMN. Okay. What are the reactions catalyzed by FMN and what are the reactions catalyzed by FAD? Because this is flavin mononucleotide and this is flavin adenine dinucleotide. So, now see, and they are used as redox reactions. So, if we talk about FMN, FMN is required for a very important reaction, oxidative deamination. Oxidative deamination, where the enzyme is L-amino acid oxidase. And the most important feature about this is auto-oxidizable reaction. So if we talk about the reaction here, we can simply say that L-amino acid, because whenever we talk about the absorption of the amino acids, L-amino acids are easily absorbed. So this, in the presence of amino acid oxidase enzyme, is going to form the keto acids, giving out amino group. And since that is auto-oxidizable, which means that FMN is converted into FMNH2, and which is coupled with hydrogen peroxide. That is why this reaction is auto-oxidizable. And this is the only reaction in the body which requires FMN as a cofactor, coenzyme, right? Then second is the other form, which is FAD. Now if we talk about FAD, there are so many reactions in which FAD is used. So if I talk about the first reaction, it can be deamino acid oxidase, then it is required for xanthine oxidase, and the most important reaction catalyzed by FAD is succinate dehydrogenase, which actually gives rise to complex 2 of electron transport chain. Succinate dehydrogenase. You can say that only enzyme of TCA cycle present on the inner mitochondrial membrane, and it is of complex 2, and it has a very low redox potential, and the reaction is succinate is converted into fumarate, and SDH, as I have written the name of the enzyme, and FAD is converted into FADH2. And it has a very low redox potential, very low redox potential. That is why we say that one molecule of FAD will always give 1.5 ATP molecules on hydrolysis. Right, so these are the, you can say, components of FAD and FMN. Then we come over to, or you can say these are the biochemical functions. Then we come over to what are the deficiency manifestations. Now, if we talk about the deficiency manifestations here, initially the patient is totally asymptomatic. Initially asymptomatic. Right, but in the later stages it leads to cheilosis. Right, so what happens basically in cheilosis? There are pallors in the angles of the mouth. The angles of mouth. Right, there is maceration of the epithelium. Maceration of the epithelium. Second is it will lead to glossitis. In glossitis, basically you can say the color of the tongue changes. It has a it turns into magenta. So magenta color tongue is there. Right, and because of this what happens is the papillae which are present on the tongue, they are lost. So basically tongue doesn't have any kind of taste sensation. So the papillas are lost. are lost on the tongue. So no taste sensation is there. Right. Then again it leads to stomatitis. Fissures are there. Right, at the again angles or here like that. I'll show you the picture also. Fourth is eyes are also affected here, and eyes may basically it leads to conjunctivitis. Right, it leads to keratitis, and the most important feature here is it leads to corneal vascularization. Very, very important. It is the most important feature. Okay, and then corneal vascularization is there. Then again photophobia is there. Lacrimation is there. Okay, so these are the features which are affecting the eyes. And then we come over to fifth one is seborrheic dermatitis. The scalp becomes totally dry, and so that dandruff and all will start appearing on the scalp. Seborrheic dermatitis. Drying of the scalp. Right, so these are the main deficiency manifestations of riboflavin or vitamin B2. Then after this, then we come over to what is the investigation here. Okay, so if we talk about the investigations, the most important point which we have to remember here is assay of glutathione reductase in RBCs. We have to check the activity of glutathione reductase in RBCs by giving FAD or riboflavin in vitro. Very, very important. Okay, so now what the question is, what is this glutathione reductase and what role it has to play in this? So what happens is this glutathione actually it is a tripeptide and it is occurring in two forms. So one is you can say the oxidized form, and this is the reduced form. Okay, so this glutathione is converted from oxidized to reduced by NADPH. NADPH which we are getting from HMP shunt. So obviously it will be converted into NADP positive and this will be converted back like this. And here the enzyme is glutathione reductase. Right, and this glutathione reductase requires B2 for its activity. Matlab B2 is a coenzyme for glutathione reductase. So what is the significance of this reductase? Ki it is simply converting oxidized glutathione to reduced form. Now what is the purpose of this? So whenever this glutathione in its reduced form, it will degrade hydrogen peroxide, half O2 like this. And here the enzyme is glutathione peroxidase. And this glutathione peroxidase requires selenium. Now see what is happening is this B2 is a coenzyme for glutathione reductase. So if I say deficiency of this vitamin is there, that means this enzyme cannot work. If glutathione reductase cannot work, so obviously the you can say fragility of RBC's membrane will be there. The membrane of RBCs will become more fragile. Okay, so this becomes, and whenever we check the activity of glutathione reductase in RBCs, if a person is deficient of riboflavin, the activity will be decreased. As simple as that. So I can say that ki B2 deficiency leads to decreased activity of glutathione reductase in RBCs. This is very important. And B1 deficiency leads to decreased transketolase activity in RBCs. So both are different. B2 deficiency will always lead to decreased glutathione reductase activity in RBCs, and B1 deficiency will always lead to decreased transketolase activity in RBCs. And if we talk about the RDA of this, the RDA is 1.5 milligram in a day. So this is Warburg's yellow enzyme, and most commonly it is known as riboflavin, whose active forms are FAD and FMN. And the most important function is it always leads to the I would say oxidation reduction or typical redox reactions, and there are two B complex vitamins B2 and B3 which play a very important role in as a electron donor or an acceptor depending upon the status of the reaction. And deficiency of this, I'll just see if the images are there, I'll just share the images with you. That deficiency of glutathione reductase or deficiency of riboflavin will give rise to cheilosis is there, glossitis is there, corneal vascularization is there, there will be ulceration in the epithelium, right, and seborrheic dermatitis will be there. So these are the things which will be caused due to the deficiency of riboflavin, which is totally different from you can say totally different from B1 whose active form is TPP. Here you can see these are the two images. So you can see that, so you can see the picture that this is the magenta color tongue where you can see there is no papillae and corneal vascularization is there. So this is vitamin B2, riboflavin, FAD and FMN are the active forms. So that is all in this video. Thank you so much.